Hello, everyone. Welcome to Think Academy. And today, again, we will be cracking some of our Uceed previous year's question papers. So, if you guys don't know, Uceed is annual design entrance examination, and the colleges that you can see on the screen, including IITs, the most prestigious colleges in India. You guys can pursue your design education there if you crack UC. All right, so let's move on to the question. I hope that people don't have any doubts about UCEED in general. We'll jump into the topic. All right. So, just before we do, I am Nandini. I am a current alumni and I'm a designer from National Institute of Design. And currently, I do product interaction and UI UX, pretty much a design generalist. And I also like to work on the past papers with you guys and see what is to be done, how to crack it, and how to do it properly. All right. So today's question was an old question based on a particular type of user, which was a visually impaired user. All right. So this is a very common question that comes in NID, NIFT, and UC, where you have a visually impaired user, and you will have to design a product for them, which means that you will have to look at special needs. You will have to look at accessibility design guidelines, and you'll have to throw in these words like universal design, inclusive design, and all of those things, so that your profile, or your answer sheet stands out, and pretty much you give an impression that you have a better understanding of what these things mean and how we can tackle these questions in a more professional manner as a design professional, right? And not just somebody who is just trying to kind of you know guess things in the air. So before we jump into the question about designing a product for a visually impaired user, let's look at, or let's kind of understand pretty much what visual impairment means, right? So first off, we might have thrown around the word blind a lot in our past, but the fact is that visual impairment is a spectrum, and the concept of being completely blind is pretty rare. But a lot of people with different types of visual impairments, as you can see in the screen, right? These are just representations, and there's more types out there. They will all come under the visual impairment spectrum, and they will all be requiring different types of accessibility tools and different types of products that are designed for them, or they might prefer certain things which are more useful for them, right? And another thing that you guys will have to bear in mind is that not everybody that is visually impaired if is proficient in braille, because most of the time okay, we have someone from IIT Bombay. All right. All right. Nice. Most of the time, what happens is that these guys are not proficient in Braille, and the designers, they heavily depend on Braille as a tool to communicate through the product. So I've seen these elevators with these buttons on them, and the buttons have these Braille, markings on them. But how do we make it accessible for a broader spectrum, right? How do we break the language barrier? How can we intuitively say that this is the first floor, second floor, third floor? At least in a building where there's just 6 floors, do we really need to go with Braille? Can we just have like one block, 2 blocks, three little squares? Like these are things that you can think of as a designer. Let's move on to the next part. And right. So someone asked, ma'am, can you explain DAT? I'll get back to that. all right, because we are discussing Uceed right now. um, First thing that you guys have to think about is break away from the whole using braille as a medium, and rather there's a multitude of things out there. There is what sound, haptic feedback, right? There is textures, there is materials, there is temperature, actually heat, right? And another, I just threw around the word haptic. So you guys, if you whenever in the notes, whenever you guys are writing your explanation or writing your concept, if you throw around proper words like haptic, it means like sensory feedback. Like sometimes in, if you guys have happened to use the face ID recognition in an Apple iPhone while downloading an app, after you double click and recognize your face, it vibrates a little bit. So it's kind of like a double reassurance that yes, this happened and we have processed it, right? So this is something that you guys can use these words: haptic feedback, universal design, right, inclusive design. But again, be very cautious and be very well read about these terms while using design jargon. And because the worst thing you can do as a design aspirant is to misuse the word, and that's it, that you'll be put in the hot seat and they will roast you for it. All right. So beyond that, another consideration, like a design consideration we have, is the shape and the size, right? So when we say size and shape, we can, it's not just like right here, over here I've given a typography example, right? But we have a huge range of things when we're talking about buttons, right? And the other day I saw an example where there was a guitar designed for people who have muscle dystrophy, right? So all these things, the shape, the size, and things, especially when it comes to things that have to be pushed, pulled, or turned, a little bit of tolerance can be widened, right? Like a little bit of, okay, maybe I did not put it right across the slot, but if the tolerance is greater, especially for people who are visually impaired or people who need a little bit more help with their dexterity, again another word you can throw in, dexterity. So in those kind of scenarios, yes, it is absolutely useful, right? So another okay, so here are the 7 UD principles. So UD stands for universal design. And what exactly is universal design? So universal design is literally what it means: universal, which means like it's open for everyone. So it's a little different from inclusive design, right? So it's equitable. And what that means is that if I have to use it, or a 90-year-old has to use it, or like a 7-year-old has to use it, or somebody who's visually impaired has to use it, the gap between the pain points will be very less, right? It's very equitable and will be very flexible, and it will be definitely again the best quality in a well designed product: simple and intuitive, right? If you keep things complex, if you add more features, and if you have like so many buttons and so many things going on, it's not going to work. And I can tell you, when I was 18, when I was trying to crack my design entrance, I had this preconceived notion that, if I am designing a gadget, let's say a product, the more features I add, the more buttons or the more cool things it can do. Like I used to be a fan of Spy Kids. So the more cool things that this one particular thing can do, I used to think that it's a better product. And after I got formal design education from NID, I realized that less is more. And that is the end of it, because as human beings, we don't care about the extra. It's honestly not that useful. We just want efficiency and something that you see it and you know exactly what it's for. That's what the word intuitive really means, right? Again, easy to perceive the information. Let's not go into the whole TV remote kind of details and designs, never going there. And again, like I said earlier, a little bit of tolerance for error, right? So that's I'll show you really nice examples in the coming slides about this. And again, low physical effort, especially if you're designing for an inclusive user group, right? And accessibility, approachability, and of course low maintenance, right? It could be something like, let's say that I designed a kettle for someone who has arthritis, right? It could be the most easiest thing to pour, easiest thing to heat water in, easiest thing to use. But if I am finding it difficult to pick up and wash or maintain, then there is no point in having that kettle, right? So, right before we move into this, let me just see. Um, okay. So here are just a few examples. This is a concept that won the Red Dot Award, where there is tactile feedback. And this is actually a toy for young children, and this is actually quite interesting, right? So this is actually a real problem that you might have as a visually impaired person, that if you have an extension code, how will you know what is what unless you decide to memorize all the shapes or something like that? So these braille tags come as quite a lifesaver, but again, I would urge you guys to move past the whole using braille as the solution for everything. So let's see what else is there. Okay, this is a prototype, actually it's not a refined product. But do we have to consider physics and chemistry while designing a product? So you will have to consider common law of the world, how things work. And you do not have to, at least in this exam, go into complicated mechatronics. You don't have to go into, okay, this is what I am going, these are the lines of the code that I'm going to write for my Arduino. Okay, you guys don't have to do that in this level. That you can do in the fourth year of your design college. But right now, some basic things, right, like a heat sensor, if you're writing it, just label it. And like, or it's just some things that are of basic common sense you guys can do. Like if you guys have a heating element, obviously you're going to cover it with something that is going to protect the hand. So those kind of things, you don't have to go into a lot of technical details, right? All right, so this product obviously is for people who want to pour without while being visually impaired. It gives a kind of like an auditory feedback. And I have done one particular project with visually impaired people. So it was quite a similar project where I had to work with a water dispenser. So in that, they mentioned that they understand through years of experience, and while you're filling the cup, right, the pitch of the water falling, it the pitch goes high, and that's how they know when to stop pouring, right? So it's quite amazing how people find a way around things. But at the same time, imagine a visually impaired 7-year-old. Okay, in that use case, this might be quite useful. So this is where user testing and usability come into play, and where things become much more interesting, because as a designer, we have to completely immerse ourselves in the user's shoes. And we can only do that by interacting with the users, by doing user interviews, user testing, and all of that. But at the same time, in this scenario, for your particular exam, just work with what you know, and just keep it as simple, intuitive, and practical as possible. Okay, so again, this goes really well, this particular one goes really well with the example of, what was that word, sorry, that example of tolerance, right? So over here, if you can slide in over there at the top, there's a lot of tolerance. And then it's pretty much like a guideline for you to use a socket. And this is, honestly, in my opinion, it's a great design, because as a visually impaired person, it would be dangerous to put your hand in a socket and feel it, right? So it gives you a lot of flexibility and independence, and that's pretty much what we're trying to do with our work every single day, right? All right, now let's jump into the real question. So, this was the real past paper. I'll read it out. In the world of the visually impaired, and in the bracket over here, they've given fully blind. All right, so over here, we are not considering the spectrum, we are considering only fully blind individuals. There is a need to equip them with special products that will help them carry out their day to day activities with ease. One such product is a pair of scissors, which can be used for cutting liquid pouches, cloth, paper, etc. So, over here, the important thing is a pair of scissors that can be used for cutting liquid pouches, cloth, paper, etc. A range of products, a range of materials, right? So, it's not going to be your tiny safety scissors. You will have to make it a little more, you know, accommodative for all of these listed things and maybe even more. Your task here, all right, so this is where you break it down, because by reading the first part you can go into 6 months of research and even more into how to go about it, and you can create so much of content. But we have to be very direct about what we are going to present or what we are going to write, right? So your task here is to design a new pair of scissors for the visually impaired. You can make use of new technologies if needed, right? So over here, this is quite interesting. You can make use of new technologies if needed. So please please keep in mind that it should be something that is real, and it should be something that is applicable, necessary, intuitive, and it's something that makes things easier, not harder. In a lot of scenarios, students have in their mock exams added high end technologies, let's just say like an AI filter, in instance, to sort out or tell you, through auditory feedback that, okay, this is the path that you have to cut it in to get the best shape, let's say, hypothetically. But is that really something that would improve your quality, or is that something that will confuse you, especially as a visually impaired? How much of detail do they expect in 30 minutes? Yes, so I will show you what kind of quality I've drawn it out. I'll get there, but just jumping the gun. They want it to be a good quality sketch, and it should be a product drawing. It shouldn't be like shading. Okay, there shouldn't be like, obviously I've done color, but they are not expecting you to color, but they are expecting you to have clean lines. They're expecting you to annotate it and talk about it, and whatever is the important features, they are expecting you to draw it out, right, and work on it. So let's jump into this. Identify at least 5 distinct factors for designing a pair of scissors for the blind. Write this briefly in the space provided. Right. So they are asking for 5 distinct factors. So these can be 5 keywords or 5 attributes. Let's say, let's use the word attributes, and you have to write them briefly. So we can go with one heading and a one liner, one heading, one liner. Keep things precise, right? Please do not paraphrase these kind of things, especially if they've given a number 5, right? They are expecting something in a bullet sort of format. All right. So, generate at least 3 concepts, pencil sketches, brief notes if necessary, and your final concept. So, over here, they want 3 ideations and one final concept. Please do not assume that B and C are the same, right? You are going to give 3 ideations and you're going to pick one and sketch it up, maybe even improve it in your final sketch, and that is going to be your final concept. So over here, the the three let's say the 3 concept sketches, right? So these are going to be a little more low fidelity, But again, please use clean lines, use an HH or a very light line pencil, use very crisp lines. But these will be more of ideations, thumbnails, and over here annotating is going to boost up your paper to the next level, and which is brief notes, right? And don't paraphrase it, just whatever you're thinking, right? A single hand, bigger groove, right? Texture over here, right? Ergonomic grip, right? Those kind of things. That's what they mean by brief notes. You're annotating, and then you are going to synthesize your final concept, which is going to be a refined drawing. So obviously you're going to spend the most amount of time on this after your conceptualization. So one pro tip is that the ideations, you have three options. So one can be something that is a little practical, and the remaining two can be as wild as possible. As long as the technology, like there is a proof of concept, you can use the remaining two ideations or at least one ideation to show that okay, this is how wild I can think, and I am not afraid to incorporate technology into my design. I am not going to stick to a simple product design, simple mechanical thing. I am not afraid to be like, okay, let's, if I go high fidelity with this, let's go and sit and crack what the mechatronics, what the details of this will look like someday in the future. Because that those are the kind of students they need, right? And that's the kind of people that we are in the industrial design community. All right, so over here they've been very clear about the evaluation criteria and everything. So this should be kind of very obvious about the sorry, this this is like a very obvious guideline of where you have to spend most of your time, right? Final solution is 10 marks. So they are expecting a high quality sketch, proper annotations, and whatever area is important, you have to be very clear with your lines. And another thing, let's say that the whole form is one, but a very small area, let's say a hinge, you want to talk about it a little more, you can draw a small arrow and annotate, and you can draw a more enlarged version of it. You have to manage your space, again, composition, okay? But you can always do that. It's not like in that one particular sketch you are drawing everything. All right, so let's look at a few examples, and let's look at how I would break this down before moving into the final sketch. All right. So this is the first thing that comes into everybody's mind, right? And this is something that is out there, and this is a accessible design, but this is something where they haven't broken away from the form of the scissor, right? It's like, okay, I have a scissor, now I'm going to add a handle, and now I'm going to add a base, and let's you have to break away, think outside the box, and be like, what all can still be considered a scissor, right? There is this very interesting way I look at it. um, a Subway is a sandwich. If I put some curry in between two chapatis, it's technically still a sandwich, right? And then the question is, again, I have two breads and then filling in the middle, it's a burger. Is burger still a sandwich? So that is like the borderline, right? So burger is a borderline sandwich. So it's a funny concept, but once you start thinking in that angle, you will start finding things where it's a borderline scissor but still a scissor. So this is like so innovative, and it's pretty cool, right? So you have to think to that level where you categorize a burger as a sandwich. Okay, probably a lot of people think I'm very silly right now, but this is just a small exercise that I do in my mind to kind of break away from creating designs like this and being very mainstream, and being one of the 2000, 3000 people who is in my city who would think this way, right? I want to be somebody who is extremely innovative, and this is a good way to crack it. All right. So let's look at one of the main pain points. One is the main one is that if you're visually impaired, you are not going to know where to start, where to end, and the route, right? So it's going to be difficult to locate the cutting line. So this is what you're going to do first. You're going to first identify what are the difficulties, what am I trying to solve, what is the problem that I am going to overcome, right? So in design jargon we call these pain points. So even in your little notes, you can just use the word pain point, which is a jargon. So it is going to be, quite impressive for them, and it will be nicer to, read that coming from an evaluator of the design community. So yes, it is going to be challenging for them to position it and decide the cutting line and have a good form of the cutting line, have a good straight line or a curved line, or even while cutting how to not have those jagged lines. So that is one of the main primary pain points if you're talking about a visually impaired person, and in our case a completely blind individual, right? Moving on, lack of visual feedback. So over here we have three subcategories, right? So you can solve this, like, by auditory, tactile, or even haptic. Okay, so tactile guiding systems are something that is there in our everyday environment for a lot of reasons, and a good reason is to make the environment more accessible and user friendly for visually impaired people. And I'm pretty sure most of you have seen these guiding tiles in a lot of places like IKEA and DMart and even public places. So these are just an example of tactile guiding system. And this can be used, or the same thing can be applied in products. Maybe it can just be like a streak or a line, or a array of dots, whatever. But this is something that we can apply to solve the lack of visual feedback. Next is an audible cutting assistant. So this could be either like I have a smart scissor and I'm pairing it to my phone and I'm speaking to the scissor, and it's probably telling me, I mean, let's go borderline science fiction with this. And it's pretty easy to do nowadays, because you have a lot of these toys which are like a particular pen, and then you glide the pen over text, and the pen reads it out. It's a play school toy that's available in Hamleys also. So something like that, but audible feedback. And then we have adaptive force adjustment or haptic feedback. So this is used where the user is trying to cut something, but if there is nothing, or if this is the wrong place to cut, maybe the force can be adjusted, right? So one area where this happens is the robotic arms. So this is the most flexible kind of robot design that exists right now. So this guy over here, Aerobot, it can with precision lift a biopsy slide without cracking it, which is another interesting project that I have worked on. And it can also lift something quite heavy, and it does that by just having that kind of adaptive force adjustment. It does that by itself, and that is a technology that you can incorporate in this, right? So you have to be well aware of what is out there to kind of apply it in our products, in our designs, and have an edge in this competitive scenario. So these are the three ways in which I would compensate for the lack of visual feedback. And then again, another problem or another pain point that I have is safety, right? So when it comes to safety, again, there's sharp edges on one side, and there's another part where we have to hold and we have to press down. So how do we solve that? So one way is that we have haptic feedback again. So I hope by now everybody's aware of the word haptic, right? It could be a beep, or it could be a vibration, or it could be like a clicking feedback, like when a lot of people enjoy using mechanical keyboards for this particular reason, that you get that haptic feedback and you feel satisfied that, oh my god, I'm typing in this. It's very satisfying. So there's multiple ways in which a particular, even the vibrational feedback, there's like a range of variations, and each thing can communicate something. So these are all ideas that you can apply into this particular design. And then there's this one particular blade that has automatic blade retraction, and it recognizes that, okay, now this is something that I can cut, so it'll be out, and then the minute it's regular air or something like that, it retracts. So maybe we can have something like that. You all have to start thinking outside the box like this, right? Again, another pain point is inconsistent cutting. So like I mentioned, it could be jagged or it could be the wrong line. So if you want a straight line, we can probably have like a straight edge attachment, like how we have for those woodworking tools. We have our saws, right? Our huge industrial grade saws, so they will always have like this edge. Or even this something very interesting that I saw in a design for a pen, a guided rail system. So this is easily, we can apply it to the scissors design as well, or even like a haptic curve tracker. So you can think about how you can throw that into the form of the scissor, right? So these are all basically different areas or different branches of a particular product's problem that you guys will have to crack, and you guys will have to think about. You guys are not going to think about the first thing, the first problem, the first solution, and start sketching. You guys will have to explore this much mentally and ideate, doodle, thumbnail. And before you before you put in your final three ideations, which ideally will have the space for thumbnail sketches. So these will be your thumbnail sketches. You guys are going to thumbnail a lot in your rough sheet, and of course you will have to manage your time. That is a real challenge here. But how to do it well, I can tell you that this is how. So again, they've asked for 5 factors to consider while designing. So these are my 5 factors: limited orientation, ergonomics, and tactile feedback. So do I use textures, grooves, something like that? Because these people rely heavily on touch. And two things that I would focus on is comfort and control. When it comes to ergonomics, there is comfort, like, okay, this is easier for me to hold, and also control. How can I hold it in such a way that it's still under my control? Like, everything is the way I command the product, it works, right? That's the whole point. Again, third one is auditory feedback. So this is something where there's 2 ways to do it. Either you can make a very high tech scissor, go over budget, because again, it's just a concept, right? Go with a haptic system or auditory feedback systems or something like that. Or you can rely on the very natural sh- snap sound of the scissor. Or maybe you can have like a clip or something by the end of it, so once everything, the whole thing is done, it makes a sound. You guys can go crazy with ideations for it. But my main point is to tell you guys that you guys have to explore all these realms before you start ideating, right? And that is the whole point of today's session, not the final product. Because once you have all of this nailed down, this is pretty much like the blueprint for designing like a plethora of ideations based on at least 1 to 3 of this. You can make one ideation, 3 to 4 you can make one, 5 itself can be one, right? Or all of this together you can make like a master product. But yeah, just don't incorporate a ton of features into one and overwhelm the user. That's the only thing to keep in mind. All right. And then again, blade safety. So we talked about retracting, or a lot of things we can do with that. And tactile alignment guides, right? So it could be scale, it could be voice telling you what to do, right? A lot of things can happen. Adjustable sharpness, yes, that sounds very cool. I would like to know how we could adjust sharpness though. um I mean, we can do it. If it was like a chainsaw kind of thing, we could easily adjust the sharpness with the speed, right? If that's what you mean. But if it's like a single blade with a single action, I am not sure. Wait, will we be only using pencil in? Yes, your tools will be clearly mentioned, but primarily you will be using pencil, and everything else you guys can keep everything with you, but it will be clearly mentioned. But my rule of thumb is carry everything with you till you step into the exam hall, because over there, anyways, they will have screening and they'll check everything. So whatever you don't need, anyway, it's going to be below 100 rupees. Even if you throw it, it's not going to hurt. But carry everything with you. That's my rule of thumb. All right, don't risk it. All right. So I did this. My the meet started at 8:30. I started sketching this at 8:20. So please don't judge the line quality. But I just wanted to convey a concept very quick, right? So over here they said mention the material, so that's the first thing that I did. I have a plastic casing, stainless steel blade, right? Again, I've annotated it very quickly, and I've used straight lines and very confident curves to kind of work with the ideation, right? And again, over here I'm showing that the paper goes into the slot. There is a huge tolerance, right? And you can see that these lines are the guide assist, right? And the only thing that moves from the hinge is the ergonomic handle, which will come and snap. So what I've done here is I've broken away from the form of a traditional scissor, and rather I've kind of subconsciously, I just realized now, got inspired by a punch hole machine. But instead of the punching blades being small circles, it's going to be one big blade, and it's going to punch down, right? So this is again mixed with the guide assist, and this is just one version. But again, if within 10 minutes you can come up with this, I'm pretty sure that, if you guys have like a solid 20, 50, like 30 minutes, you all can come up with a lot of good concepts. But yes, this is pretty much it for today. Labeling is important, right? Yes, annotation is very important, and they will pretty much judge you based on how you're going to communicate, based on your annotation and based on your lines, right? So I've used contour lines over here to kind of convey the form. I've used the straight lines to convey that, okay, this is the perspective that I'm drawing in. And yeah, any other questions, guys? Any other questions on any of these slides, or in general? All right, no. Okay, hope you guys enjoyed this session. And if there is any particular topic or any particular year's paper or question that you guys want me to crack, you can always drop a comment. I'll be more than happy to discuss with you guys. And yeah, thank you so much. All right, bye bye.